All right, so in this particular example, they give us that x is equal to 2 tangent theta. It's in the first quadrant between 0 and pi over 2, theta that is. And they want us to write 4 plus x squared as a function of theta. So basically the idea is that instead of this where we would input an x, we want to be inputting a theta. So we're going to start with the expression that they want us to turn into a function of theta, okay, and then we're going to use substitution. Well, up here I state that x is equal to 2 tangent theta. If we do that, we're going to see that we get the square root of 4 plus 2 tangent squared. Well, that in fact is just equal to the square root of 4 plus 4 tangent squared. Well, I can see here that I think that I actually have an identity somewhere in here. If you can't see that, whenever you see a squared term like this, I start thinking Pythagorean, and I can see here that, well, I have this greatest common factor, so why don't I factor this out and see if I can discover one of my identities. And I divide the 4 by 4 and I get 1 plus tangent squared. And if you go to your formula sheet, or sorry, your identity sheet, one of the identities literally is simply that secant squared is equal to 1 plus tangent squared. That's one of the Pythagorean identities. Well, from here, I can go ahead and simplify this out slightly, and I get that 4 times secant squared. Again, we see that here, that this is equal to secant squared, okay, is a more simple version. Well, and since these are both squared terms, I can actually just go ahead and take the square root, and I get 2 secant theta. And I know that because I started with my original function, that this, in fact, is a function of theta that is equal to, or the same thing as 4 plus x squared. And I could write this here as that this is equal to f of theta if I wanted to use function notation.